All right, number 9. 6 people out of 8 missed this one, and I think it just came down to reducing that function up top. Okay, so with that absolute value, we're going to run into some problems. That means we're dealing with maybe if we look at the limit as x approaches 1, if we plug a 1 in there, we've got a 0, and then we get a 0 on top. So it won't work just direct substitution. So we need to reduce this somehow. And the absolute value means we need to concern ourselves with the negative aspects of it and the positive aspects of it. So let's look at as x approaches 1 from the left and as x approaches 1 from the right. How does that change this? Okay, so I'm going to start up here. Do I have room? There we go, on the screen. Okay, so we got our 2 binomials here, and then as we approach from the left, as we approach 1 from the left, this will always end up being negative, right? If you plug in 1 directly, you're going to get 0, and then anything from the left of 1, including 0.5 or 0 or negative 0.5 or negative 1, so on and so forth, if you plug those in, you're going to end up with a negative value there, and so we end up with a negative x minus 1 for x is approaching from the left. So I'm just going to put an L here from the left. And then let's look at it approaching from the right. And so if we approach 1 from the right side and get closer and closer to it, this is always going to be a positive. So that means we're going to have the same. Am I still on screen? I am. Okay. It's basically the same setup, except we're dealing with all the positive values of this binomial. So I guess what I'll do is I'll put a plus out there. You know, not really going to change too much. Okay, and so let's take a look at from the left. This is from the right. We will end up crossing this out with one of these. And so we're left with x minus 1 times x plus 1, but that negative is going to pop up top as well. Okay, and then here we're just going to direct cancel one of those, and basically the same thing, but just positive rather than negative. And now we can maybe try and reevaluate this when x equals 1. So let's try that. We plug a 1 in here. We end up with a 0 times whatever. Negative 0? I don't think that's a thing, so we won't even worry about the negative at this point. We plug a 1 in over here. We get 0 times 2, which is just going to be 0 again. Okay, so the limit as we approach x from the left is 0, and the limit as we approach x, as we approach 1 from the right is also 0. So as we approach from the left it's 0, as we approach from the right it's 0, well, that just means the limit is 0 since they're the same.